In this video, we are going to do our best to connect our original function, our first derivative, and our second derivative. And so what we're going to do is we're going to be looking at different chunks of graphs and basically determining everything that we can about the original function, its first derivative, and its second derivative, given in this scenario we'll be given the original function. So I would recommend maybe finding three colors to work with. So for example, my original function is going to be red. My first derivative is going to be blue, and my second derivative is going to be green, because this will just kind of allow us to keep everything organized, neat, and come to every conclusion about every piece of these graphs. And so making these connections is going to be really helpful because in a lot of calculus, they'll give you just one piece of information and you have to determine from that piece of information what's happening to your other graphs. So if they give you some piece of information about your first derivative, you should be able to tell me what's happening on the original function as well as on its second derivative, if possible. So, all right, let's go through and talk about these pieces, or these major curve pieces. So in part A, this is my original function, so what can we say about g? Now it's not located on a graph anywhere, so I can't say like what the values of this graph are. All we can talk about is the fact that I know as I follow my graph from left to right, it's going up. So I would say for g that this is increasing. So if my original function g is increasing. Okay. And then what does that tell me about my first derivative? Now, if I'm talking about my first derivative, are the slopes on this graph. And so as my slopes are doing this, what are all of those slopes? What can we confirm about any slope that's on this graph? Well, we can confirm that if my original function is increasing, the slopes of that graph are positive. So g prime is positive. Okay, so that's one piece of information we can gather from here. One other thing that I can know about this graph, the original function, is that I know that it's increasing, and then in terms of my second derivative has to do with concavity. So then I can confirm that my original function is concave up. And so that conclusion leads me to know that my second derivative is positive. And then the one in between piece that we want to talk about here is that this kind of collection. So I knew that if I had a graph that its derivative was positive, that original function would be increasing. So if my second derivative is positive, that means my original quote unquote function for that this graph is also increasing. And so that's a new conclusion that we can confirm. And I like to pull it from the fact that my second derivative is positive, but you can also talk about it in terms of your original function being concave up. So not only are my slopes here positive, right? So this looks like it could be, like we could call this a slope of 1/2, and then we could call this a slope of 1, and then this is a slope of like 3/2, and so on and so forth. Not only are all of these slopes positive, but they're also increasing. And that comes from the fact that my second derivative is positive because my original function is concave up. So these are the types of connections that we're going to be making. And so if I give you just this one piece of information, you should be able to confirm these other two pieces that are associated with it. Or if I give you just that my original function is increasing, I can confirm that my first derivative is positive. So that is how we're going to start being able to connect all of these major pieces. And we'll do more like re-encoding of this information. So we'll look at it in different ways. I'll have you make different resources that help combine the information correctly. But I just wanted to touch base about it today. And so now let's go ahead and we're going to scoot on over to this next guy and we're going to talk about what we know about this guy. So I'm going to kind of use the same setup, but describing the different pieces that are happening. So this is no longer an increasing function. So I would say for part B, G is decreasing. And then you can kind of identify, well, what does that mean about G prime? Well, if G is decreasing, then my slopes of that graph definitely are all in the negative direction. So if G is decreasing, G prime is negative. I also know that G is concave up, right? It still looks like it's part of a valley, and so I can come to the same conclusions about G prime and G double prime. So G prime is increasing, and then G double prime is positive. Lovely, right? So these are these conclusions that we need to come to. So I should be able to ask you, or I should be able to say, hey, I know that G prime is increasing. What else do I know? And then therefore, straight from there, you could tell me, oh, well, G is concave up. G double prime is positive. And kind of understanding the why behind it is helpful, as well as just working with it a lot will just kind of encode it into your brain. All right, let's look at these next pieces. So in this scenario, my function is decreasing. So G is decreasing, which means that my first derivative is negative. My slopes of the tangent lines of that graph would be negative. And then my G here now is concave down because it looks like part of a hill, which first and foremost in my mind pops down to G double prime is negative, which means that if this derivative is negative, it's original. So if the second derivative is negative, that means the first derivative is decreasing. And then we have one more piece here. So we have this function, which is increasing. So G is increasing, which means that G prime is positive. But then this is still concave down, so I can still write G is concave down. And G prime is still decreasing then. And G double prime is still negative. Awesome. A couple of things that I want to connect as far as wording goes. So when we talk about this graph, and you'll see this often talked about as far as rates go. So I could talk about this function increasing at a particular rate. And so we can use the same information to kind of talk about that. So I would say that for D, we would say G is increasing, but at a decreasing rate. And that makes sense, right? I'm increasing, but I'm getting smaller and smaller and smaller. So I could say that this graph is increasing at a decreasing rate. Okay. And then I want to go back up to this one because we could say that this one makes sense too. We could say that this graph is increasing at an increasing rate. So increasing at an increasing rate. But B and C are where this starts to get a little bit funny as far as how in regular, like layman's terms, so for just your normal everyday Joe Schmo, how they would talk about this curve. So if I was a Joe Schmo, I would say, well, this graph is decreasing, but it's doing it like it's decreasing less at the end, right? It's getting more positive. So I would say almost that that's decreasing at a decreasing rate. However, if we look at our actual calculus piece, we know that this function is actually decreasing at an increasing rate because while your graph is decreasing, its slopes are getting more positive technically because it started off at like -5 and then now it's at -3. And so eventually if we carry on with this graph, it will end up having positive slopes. So I would say that this graph is technically decreasing at an increasing rate. a lot of people would like to like identify that an increasing rate means faster. So like this would start decreasing faster and faster and faster, but that is not what it means in calculus. So decreasing at an increasing rate. And then in part C, we would say that this is decreasing at a decreasing rate. How about I learn to write? Because it's decreasing at a decreasing rate. Okay, so the C. This is pretty tricky to remember, and so is this one. These ones make sense. Increasing at an increasing rate, increasing at a decreasing rate. The decreasing parts are the ones that are a little confusing. So make sure you extra write those down.